Hello there. Do you know that atoms form the basic part of human life? In fact, everything in and around us is made up of matter, which we can stem down to atoms being a vital part of those things. In fact, if there is any word that should be passed on from generation to generations, be it knowledge, be it idea, that statement is what you have on your screen, that everything in and around us is made up of matter. In this video, we're going to look into atomic structures and how they work. Atoms are the smallest particle elements that can exist. That's long before now. The definition of atoms was that it is the smallest indivisible part of matter, but we've gone to discover that there are still protons, neutrons that can still be separated. That's why we refer to it now as atoms are the smallest particle of an element that can exist. So far it can exist in space and time, then it qualifies as an atom. Now there are three particles in an atom. You have the protons, you have the neutrons, and you have the electrons. We're going to talk about all of this in this video. The proton and the neutron, that's what you have in the nucleus. Okay, the huge mass of red ball and green balls, those are protons and neutrons in the nucleus. Then surrounding the nucleus in a cloud, that's where you have electrons hovering to and fro, revolving around the nucleus. Each particle has its peculiar property in terms of the charge and the mass. For example, the charge on the proton particle is plus 1.6 times 10 raised to the power of minus 19. Neutron has a charge of 0. Electron is negatively charged, 1.60 times 10 raised to the power of minus 19. Then the mass in kg, in kilograms, for proton is approximately 1.673 times 10 raised to the power of minus 27. That's in kg. Okay, the charge is in coulombs. Let's just have that here. The mass is in kg. Then the mass of neutron is 1.67, approximately 5 times 10 raised to the power of minus 27. Then electron has a mass of 9.11 times 10 raised to the power of minus 31. Okay, now from this, now you can see that the mass of an atom is mostly contributed by the proton and the neutron. The mass of the electron is relatively insignificant. Sometimes in calculations you can be required to use some of these figures. Okay, now down to the relative charges and relative masses. For proton, we usually attach or charge a relative charge of +1 since protons are positively charged. Neutrons have no charge, that's 0. Then electrons have a charge of -1. Then the relative mass, is neither positive nor negative. We're just attaching numerical values to the relative mass. So for proton, we'll have 1. For neutron, we'll have 1 as well. Then for electron, we'll have 1 divided by 2000, which is negligible. So like I said earlier, this and this constitute the mass of the atom. So that means the mass of the atom is concentrated in the nucleus. Okay, the positive part of this particle is in the nucleus, then the negative part, which is the electrons, is outside. Now you can have a situation where an atom is stable. If an atom is stable, that means it has equal number of protons and electrons. So let's say it has two protons, that's positive 2. Let us have that as P. Then electrons has 2 electrons. They cancel each other out. Now the atom is stable. But when we're just picking numbers here, let's say we have 2 protons in the nucleus and electrons, we have just 1. These will not cancel each other out, so we can say it's unstable. Okay, so another thing that I want to mention is that don't mix up atoms and nucleus. Okay, atoms, they are like the whole package, like the total package which consists of the nucleus and the electrons. But the nucleus is just that center point of the atom where most of the mass is concentrated. That's the nucleus houses the proton and the neutrons, so don't mix the two together. So that'll be all for this video. Thank you very much, and I'll see you guys in the next video.